Bismillahirrahmanirrahim. Inshallah, today I'm going to review some of the things that we already talked about in chapter 7 in algebra, which is about linear functions and solving a system of linear functions or lines. So linear function is a fancy way of saying equations of lines. So y equals 3x plus 2. This is a line, as you know, or it's a linear function. Now, as you recall, there are three ways to write equations of line. This is ax plus by equals c. This is one way, and this is the standard way. This is the standard form of writing an equation of line. And y equals mx plus b, and this is of course the slope-intercept form of writing equation of a line. And y minus y1 equals slope times x minus x1. This is the point slope form of writing of equation of a line. So this is imperative, of course, that you understand this and know this thoroughly before we go on. So, and also before, as a review, I have suggested that if you are given 2 points, for example, and if you want to try that are on the line, and if you want to find out the equation of the line that goes through those 2 points, okay? So these are, let's assume that those are the 2 points that are given, and that's the line that goes through them. And if you want to find the equation of this line, there are 2 ways of doing this. And the first way is to find the equation in the slope-intercept form, and the second way is to find the equation in the point-slope form. So and then if you wanted it in standard form, you find it in one of these form, and then you convert that into the standard form. So first you have to find them in one of these and change that form into the standard form, which is ax plus by equals c. Okay, but if you're given 2 points and you want to find the equation of the line that goes to those 2 points, the way to do it is in these 2 forms. And the first step is easy, as you recall. First step in both of these, you have to find the slope. Can't get away without finding the slope. The second step here is once you find the slope, okay, then you find the y-intercept, find b, okay. And the second step here is you're done. Once you find the slope, you just substitute one of these points here, and you're done. You can just enjoy. And if you didn't want to change this to a standard form, you take one of these forms and change that into the standard form. That's just a review of how you find equations of lines. Now, this is an algebraic expression, as you know. This is an equation. Correct? And finally, this is a function. This is a linear function specifically. It's important to understand what exactly this represents at a kind of more theoretical level, right? For example, if I have a certain set of numbers, which I'm going to call x and y, and this is the domain and the range, or the input and the output, okay, and I say the way you get y is you take the x and add multiply by 3 and get 2. So let's apply that rule to these 3 numbers. Okay, so if x is 1 and applying this rule, so the way to get y is 3x plus 2. So if x is 1, this is 3 times 1 plus 2, okay, that's going to be 5, okay. And if I apply the same rule to 2, it'd be 6 plus 2, okay, it'd be 8. And if I apply the same rule to 5, if 15 plus 2 is 17. So this equation, this function here, represents the rule that converts a certain domain element, a certain domain number, to a certain range number. It's the rule that maps the domain input to the output, the domain to the range x and y. So when you say y equals 3x plus 2, it really means how do you take an input value, what do you do to that input value to get to the output value? It's this rule that takes it from here. Okay, that is what this is. It's the rule that takes a certain input and converts it to the output value. Okay. Now when we say there are three ways to write an equation of a line, correct? So standard, slope-intercept, and point-slope form. In the standard form, these are numbers, of course. These are certain numbers. For example, 2x plus 3y equals 7. If this is given to you, then a is 2, 3, and b is 3, and c is 7. Okay, and if you're given an equation in the slope-intercept form, okay, then the slope is 3, right, and the y-intercept is that. And if you're given an equation in point-slope form, okay, the point that's given to you is those two ordered pair. Specifically, it's going to be 5 and 3, okay, and the slope is going to be 4. Okay, so you have to have a very good working knowledge of all of this. And then we get to system of linear equations. Strictly speaking, it should be system of linear functions. The word system means just a collection, a group, or more than one. Usually it's two. So you tend to talk about system of two linear equations, or just system of linear equations. So system is more than one. Strictly speaking, it should be system of linear functions. In other words, you're given two lines, basically. So when you say a system of linear equations, it's just a fancy of saying more than two lines are given to you. So these are two separate lines, y equals mx plus b, form both of them. So this is a system of linear equations, or a pair of linear functions. A pair of linear functions. Okay, each of these, if you were to ask to graph, and I think you'd be very comfortable graphing this. So the first one would be 1, 2, 3, 4, and the slope is down 3 or 1, and you would go like that, and pretty reasonably completely graph the first one, for example. So when you're given a system of linear equations like this, however, okay, there are three possibilities, correct? Right? If you're given two lines, okay, one possibility is that they are parallel to each other like this. Correct? This happened to go there. Okay? One possibility is that they are parallel to each other like this. Correct? Another possibility is that they are not parallel and they intersect at each other like that. The third possibility is somebody could just give you the same line just looking differently. So it could be just same line written in a different way. Right? So there are three possibilities in this way. So even before we get to system of linear equations, I want to pause here and make sure you understand this concept. So this is, of course, a line, correct? So this is a line. Let's just draw this. Y-intercept is 2, correct? And the slope is up 3 and over 1. So you can graph this line, and that would be the line. So clearly in this Cartesian plane, okay, there are innumerable points that are not on the line. These are all points that are not on the line. And there, of course, there are many points that are, and those are all going to be over here, right? So if you take a random point, let's say from here, this point over here, okay, let's just pick this one. I'm just going to pretend that's 10, 0. If you take a random point that's not on the line and substitute that in here for x and y, it will not satisfy this equation. In other words, it will make this a false statement. Let's just do this. X is 10, y is 0. So 0 equals 3 times 10 plus 2. So 0 equals, this is 30 plus 2, 32. Does 0 ever equal 32? Right? Not on our planet. So this is not a solution. And we could clearly see this, not a solution to this line. In other words, this ordered pair does not satisfy this equation or this rule. So if the question says, is 10, 0 a solution to this function, or right? The answer would be no, clearly not, because it makes this a false statement. All the solutions to this function will be then the ordered pairs that are on the line itself, correct? So if the ordered pair is a solution to a function, it will satisfy the function. It will make this a true statement. Okay? So let's see if this ordered pair is a solution to this equation. Okay? So let's find out. I'm going to substitute that in there. So y is 17. Does that equal to 3 times 5 plus 2? That's 17 is 3 times 5 is 15 plus 2. 17 equals 17. Yes, that's a true statement. That means this point, 517, is on the line. Okay, so it's like there somewhere. Does that make sense? So if a point is a solution to a line, that means it is on the line. It will make this a true statement. Now going back to the system of linear equations, y equals minus 3x plus 4. And y equals 3x minus 2. Okay? Now, let me draw this over here. Y equals 3x. It's negative 3x given here. Minus 3x plus 4. That's the first line. So y-intercept is 4. The slope is negative 3. The second line given is y equals 3x minus 2. Now observe these lines, okay? Observe these lines. Look at the blue line over here. All these points over here, okay? All these points over here that are on the line over here. All these points. Any of those points will satisfy this equation. And all the points that are on the red line will satisfy this equation. But this point right here, that's 1, 1, that's common to both of them. This will be the only point that will satisfy both the red equation and the blue equation, the red line and the blue line, correct? So if two lines intersect, these are not necessarily these two lines. If two lines intersect, okay, like this, okay, the point of intersection is the only point. It's the only point that is common to both of them. It is the only point, in this case 1, 1, that's common to both. It's the only point that will make this a true statement, and it's the only point that will make this a true statement. So this point is a solution to both equations, to both functions. Does that make sense? So 1, 1 here is called the solution to the system of linear equation or linear functions. So this is the solution. That's what it means to be a solution. Now, for example, I have here just some different random lines, okay? So here's one line, and here's one other line, okay? Now, all these points that are here on this line, the green line, okay, they will satisfy, right, the equation for the green line. And all these points that are on the purple line, it will satisfy the equation for the purple line. But this very super special point right here, it will be the only one that will satisfy the green line and the purple line. Okay, that's called a solution to the system of linear equations. That's what it means to be a solution. Now, observe this one. Y equals x plus 2. That's a line. And then x equals -3. That 2 is a line. What kind of a line is it? It's a horizontal line, right? No. It's a vertical line. Okay. Now, we are asked to find a solution to the system of these linear equations. Okay. So, in other words, we are asked to solve, okay, this system of linear equation. When you solve a system of linear equation, you're looking for an ordered pair, if it exists, that's a solution to, that's common to both, or the point of intersection. Okay? So when we're solving a system of linear equations, let's just say we have two lines. This is just hypothetical two lines. When we're solving for them, we're solving for the point that they intersect. Correct? The points there are that they intersect. So when you're solving a system of linear equations, we're trying to find that ordered pair that is common to both of them. Okay? There are three ways to solve for a system of linear equations. Okay? There are three ways. Okay? One way, two way, and three way. Okay? Now the first way is a very cumbersome way sometimes, and that's by graphing. Okay? Now in here, what you do is you simply graph the two lines, okay, like this, and then you try to make your best guess as to where they intersect. Okay? And that's how you find the solution. So one way is by graphing. The other two ways are as follows. One is by substitution. It's called substitution method. And the second is called elimination method. We have talked about these before, but that's I'm going to review and talk about it again because it's important to appreciate this 100%. So one way is by graphing, okay? So there are three ways to solve a system of linear equation. One is by graphing, and then there is substitution, and there's elimination, okay? So let's do one with graphing, and we're going to do this one with graphing. Y equals x plus 2, and x equals -3. So I'm just going to be lazy here because we've done this before. So I'm just going to graph this here. Y equals x plus 2. Okay, if I wanted to do this, okay, if I was not lazy, okay, if I wanted to graph this, I would go to y-intercept is 2, slope is up 1 over 1, up like that. I would do that. Okay, that's easy enough. And the second equation given is x equals -3. Okay, this is nice. Nice help here. So this is the point of intersection, as you can see. The point of intersection is of these two lines is right there. And then you try to guess, well, it's going to be -3 because everything here is -3. It's going to be -3, and it looks like it's right here, and that looks like 1, -3, 1. Okay? So the point of intersection is -3, 1. So the first way is just by graphing the lines and making a best guess as to what they are. Now this is easy, but what if it was like this? See, it was 0.26x plus 2.3, right? And then this was x equals 3.1. So it's not as straightforward as that. Then you have to make your best guess. It could be -3.1 and 1.49. You know, it's like that. So it's not the best method of solving a system of linear equations. Graphing is. So this one way, however, you can graph lines, okay, and then try to find. So when you're given a system of linear equation. It should be functions technically, but it's popularly known as equation, but that's okay. When you're given the three ways to solve, graphing, and then there's substitution and elimination, right? So we're going to talk about substitution next. So now watch this. Now the example given is y equals 4x minus 9. That's a line. Y equals x minus 3. These both are given in slope intercept form. Slope intercept form. Correct? Now we're going to solve this using the substitution method. Okay? What that means is you take one of these lines, doesn't matter which one, and you solve that line for y equals something or x equals something. For example, if the line was given like this, okay, this is in standard form. If you wanted to use substitution method, you would have to solve this for x or solve it for y and get x equals something or y equals something. Okay? And then once you solve x and y, substitute this, okay, into the other equation. Okay, we'll do some examples of that. So here it's easy because they're already solved for us. The equation is already solved for us. So y is this and y is this. So what we do is you take y, which is this, and substitute that in place of y over here because these two are the same thing. So you substitute that in place of y. So then you get x minus 3 equals 4x minus 9. Once you substitute this over here in this y, you get x minus 3 equals 4x minus 9. And then you solve for x. Since you have x on both sides, you subtract x from here and you subtract x from here and get minus 3 equals 3x minus 9. And then you add 9 to both sides. This is 6 equals 3x, right? And divide both sides by 3. X is going to equal to 2. Now you know what x is, then you can go back and find the y by substituting for x in either one of them, doesn't matter. Okay? I'm going to do it in the bottom one here. So y is going to equal to 2 minus 3, which is negative 1. So the solution here is 2 and negative 1. In other words, if you were to graph these two lines, okay, they would meet at 2 and negative 1. Let's just do that since we have the liberty of doing that. So y equals 4x minus 9. And then we have y equals x minus 3. See? These two lines meet at 2 and negative 1, which is the solution that we got. Okay? So when you're substituting, you take one equation and then put it in the other equation. So you take this equation, y equals this, and you put it in place of y over there. Okay? So that's how you do substitution. Let's do another example of substitution. Okay. Now these are both given in standard form. Okay. And we are asked to use substitution method. Substitution method to solve this. Okay, in order to use substitution method, the first thing you have to do is solve one of these equations for x equals something or y equals something. Okay, it doesn't matter which one, but I'm going to use the bottom one because that looks easier to me. So I'm going to take this equation here, and first I'm just going to rewrite this: x minus y equals 13, and I'm going to solve it for x. You can solve it for either one of them. But I'm going to solve it for x by removing the y from this side by adding it. So then x equals, okay, it's going to be y plus 13. Now I know what x is, see. Now I can substitute this. That's why it's called the substitution method. Now I can substitute this in place of x in the other equation, not this one, okay, in the other equation. So I solve one of them for either x or y, okay? And then once I solve it and use that and substitute in place of x over there. So then you have 4 times y plus 13. That's why after you substitute it right there. Plus 2y equals 10. And then I solve this equation for y. So I get 4y plus, this is 40 plus 2, 52. Okay. Plus 2y equals 10. Now I have like terms, which I like to combine. So that's going to be 4y plus 2y is 6y plus 52 equals 10. Then I subtract 52 from both sides. 6y is equal to negative 42. And I divide both sides by 6. Let's get 42 over 6. That is negative 7. So I know what, now that I know y is negative 7. Now that I know y is negative 7, I can take that and substitute it over here. Or I could substitute over here. I could substitute anywhere because this equation is the same thing as this equation. I didn't change it, I just manipulated it. I'm going to do it over here only because it's an easier thing to do, because it's solved for x already. So I take this y and substitute it over here and solve for x. So x is going to equal to minus 7 plus 13. X is going to equal to 6. So the solution for this set of linear equations is 6, negative 7. You follow? Now, let's do it again. Let's graph this over these two. Let's see if we did this right. So we were given in standard form 4x plus 2y equals 10, and x minus y equals 13. Okay? This is where they intercept. Okay, 6, negative 7, which is what we got. Okay? Now, if you look at this equation over here, before I go on, 4x plus 2y equals 10. You can see you could have divided the whole equation by 2 to simplify it before you solved it, but I didn't want to confuse anyone, so I didn't do that. But for those who appreciate it, you can just do that and make it a little easier to solve. So again, if you're given a system of linear equations like this, okay, I'm just using these two examples. They could both be given in standard form. They could both be given in slope-intercept form. They could both be given in point-slope form, or a combination of those two. But if you're given a system of linear functions, equations like this, there are 3 ways to solve them. First was by graphing. Second was by substitution. And the third way is by elimination method. Okay? So we reviewed this, I reviewed this, and I'd like to review the third part. So the idea of elimination is this. Let's just give you a simple x plus y equals 5. X minus y equals minus 1. Okay? So now both of these are given to me. And I'm asked to solve the system of linear equation. These are lines. Okay? And I'm solving them means to find the one point that's common to both of them. So now the way elimination works is that if you just look at these two set of equations, if you just add these two equations, you notice that this is plus y and minus y. These cancel each other out. If you were to add these two equations, then you get 2x plus 0. Those are 0. The y's get eliminated. Okay? So the y's get eliminated. Okay? And then you can solve easily for x. 2x equals 4. x is equal to 2. Okay? So that's the idea of elimination. Elimination is to solve equation by getting rid of one of the variables. And in this case, it was simple. You just add the two equations and you get this, and x equals 2. Now, once you found x equals 2, you can substitute this in either one of these equations and solve for y. So 2 plus y, if I substitute in the first one over here, okay, so 2 plus y equals 5. Turn this on. Abdullah, would you please turn this on for him, so you can just listen in, inshallah. Bismillah. So if I substitute this for x, 2 for x over here, I get that, and I subtract 2 from both sides, I get y equals 3. So the solution to this set of this pair of linear equations is 2 and 3. That's the elimination method. But it's not going to be that easy all the time. For example, if I give you 2x plus 3y equals negative 1, and 2x plus 5y is negative 3. Okay? So, and then we have to solve this set of system of linear equations using elimination method. Okay? So, what do we do over here? You do what?
Times one of them by negative.
Yes. Which one?
The bottom.
Yeah. Does it matter? No. Not really. No, see, what he observed over here is that these two terms are almost identical to each other. This is 2x and this is negative 2x. You almost wish this was negative 2 so you can add them and eliminate them, right? But it's not. But if it's not, it's okay. You can multiply the whole bottom equation by negative 1 and change that to a negative, right? So if you do that, I'm just going to copy the two equations down. 2x plus 3y equals negative 1. And then the bottom becomes minus 2x, right? So minus 2x minus 5y equals positive 3. You can't forget this over here. You have to multiply both sides of the equation by that. Now, see, now you can see these two terms are opposite of each other, 2x minus 2x. And if you add these two equations together, they cancel out. So then you get minus 2y equals 2. And then you can solve for y. You can divide both sides by negative 2, like this. So y is equal to negative 1. Okay, so y is negative 1. So once you solve for y, you can substitute this in either equations over here for y, or in this place over for y. And it doesn't matter, correct? It doesn't matter. So it doesn't matter where you substitute. So I'm going to substitute in the top one. So 2x plus 3 times y equals minus 1. And then you solve for x. So 2x minus 3 equals minus 1. Solve for x and add 3 to both sides. So 2x equals 2 and x is equal to 1. So the ordered pair, that's the solution to both of them, is 1 and negative 1, like this. Okay? Now, listen, let's do this one. You have minus 8x minus 10y equals 24, and you have 6x plus 5y equals 2. Now we are asked to solve this by using the elimination method. So what are we going to do here, Mohsin?
Times the bottom one by 2.
So good. So why did you want to do that? He wants to multiply the bottom equation by 2. Why would you want to do this? Why would you want to do such a silly thing, Mohsin? Because it's not silly. Why is it not silly, Mohsin?
They can cancel out.
Yes, because see, then this will become 10, right? and you have negative 10 here and positive 10, they will cancel out. That's exactly what I would do. Now, there's one thing that I would do, that you could potentially do, okay? But most didn't do that, but that's okay. So look, I could divide this whole equation by what? By 2, right? Because 2 is a factor in every single term, correct? If I did that, I would get negative 4x minus 5y equals 12, right? Correct? Just like I can multiply the whole equation by 2, I can also divide the whole equation by 2. Correct? Now I have this. Now, not to say there you could have eliminated it that way, but that's okay. But we'll do it the way Mohsin chose to do so. Alright, now look. And I'm just going to rewrite this, the top equation. And the bottom equation becomes 6 times 2 is 12x plus 10y equals 4. Correct? Now I can add this because when you add those two, what happens, Mohsin?
You cancel out.
Yeah, these two cancel out, they get eliminated. Correct? So negative 8x plus 4x is 4x equals 28. And then x, divide both sides by 4 like this. And the x equals 7. So now you know what x is. Now you can substitute that back in either one over here, over here. Right? Does it matter? Does it matter? No, it doesn't matter. But we'll use over here because it looks like easier, right? Second equation looks easier. So 6 times 7 plus 5y equals 2. 42 plus 5y equals 2. And then subtract 42 from both sides. I get 5y equals negative 40. And y equals negative 8. So you get 7 and negative 8 to be the solution to both of these equations. Okay? Get this, Mohsin. Right? Mohsin, I'm going to give you one more question over here. Okay? 2x plus 3y equals 5. And I have minus 4x minus 6y equals minus 10. What do I do now, Mohsin?
Times the top equation by 2.
Yes, Mohsin wants to multiply the top equation by 2. Okay, let's do that. I'm just going to rewrite this. The top one becomes 4x plus 6y equals 10. And the bottom equation becomes, I'm just going to rewrite this bottom one over here. Minus 4x minus 6y equals minus 10. Now add them up, Mohsin. So what do I get?
0.
What do I get?
Everything cancels out.
So this becomes 0. And this becomes 0 plus 0. 0. And this becomes 0. So negative 0 equals, that's a good one, Mohsin. That's a very good one, Mohsin. So what does that mean, Mohsin?
Infinite solution.
Yes, this means that you have infinite solution. Okay? Infinite solution. Okay? Whenever you get something like this, or if you get like 3 equals 3 or whatever, you know what I'm saying? If it's a true statement, that means you have infinite solution. These are the same lines. Okay? These are just same lines in different ways. What I did is, I took this one, and in my mind, I multiplied the whole equation by negative 2. Do you understand? That's what I did. I wrote this one, I multiplied by negative 2. It's the same line. So when you get something like this, then it is infinite solutions. Okay, one second. Now, just to reiterate, if you're given two lines, okay, if the lines are parallel, how many solutions will you have? When the lines are parallel, very good. You have 0 solutions because they never meet, right? There will be no point that's common to them if they're parallel, correct? If they are not parallel, that means they would meet like this. Then they would have how many solutions? 1 solution. And finally, if they are the same line, like the last example that I show you, okay, like this is a green one, and then here's the same line over here. Right on top of it, I'm going to do it with purple like that. Okay, they're the same line, right? Then you have infinite infinite solutions. Okay? When they don't meet like this, right here, when they don't meet, this is called an inconsistent. Inconsistent system. System means pair, right? Inconsistent system means that there is no solution. That's another way of saying, fancy way of saying that there is no solution. Correct? So if you're given two lines, and if they are parallel, then they will never meet. There will be no solution. That's called an inconsistent system. Okay. The other two, where they do have solutions, okay, whether it be one solution or infinite solution, they are called consistent systems. Does that make sense? Okay. That's just some fancy terminology regarding these. Now let me ask you this. How many solutions will you have here? How many? I'll give you three choices: 0, 1, or infinite. Very good. We'll have 0 solution because these are what kind of lines? They're parallel lines because they have the same. So, right? If they have the same slope, correct, then they will not have any solutions. Okay. So watch this. Okay. How about this one? Okay. Let's do this. Let's solve this. These are two separate lines. Okay? These are two lines, right? Two system. This is in standard form. This is actually not in any form, but it's given. Okay. So let's solve this. You can add these together. You can substitute. How do you do this?
What am I supposed to do?
Solve them. These are two lines.
Move 2x to the other side. Bring the top one.
Yeah, move this to the other side.
2x.
Okay. And then you get what? So I get y equal minus 2x plus 5. This is the top one. Okay.
And then you can substitute.
I'm just rewriting the second one.
And then for the bottom one, you can divide y up and go to the other side.
Okay. Well, let me help you out here. Watch this. What I'm going to do here, I'm going to solve these are two lines. First thing I'm going to do is I can just get rid of this negative 1 by multiplying the whole equation by negative 1. So I get this. Do you understand? Then I can substitute this in place of y. Okay? Then I get 2x plus y, which is minus 2x plus 5 equals 5. Right? And let's try to solve for x. When I do that, the x's cancel out, see? I get 0. I get 5 equals 5. What does that mean, Wilson? They're infinite. These are same lines, see? These are same lines. Okay? What I did was, I took this to the other side and this to the other side, multiply the whole thing by negative 1 to get the other line. So these are same lines again. So sometimes it's not as apparent whether or not they're same lines. But here again, there are infinite solutions. Okay? So that's a review of linear systems. So when you're given a system of linear equations, there are three ways to solve them. The first way is what's the first way, Mohsin? Graphing. Very good. The second way is by substitution. That's the way order I talked about it today, so I'm going to keep it that way. Substitution. And the third way is by elimination. So, this is chapter 7 material, and next time I will like to do some word problems related to solving system of linear equations, and also talk about the system of linear inequalities, etc. We shall continue from there inshallah next time. Assalamu alaikum warahmatullahi wabarakatuh.